Hey there, science fans! Today, we're diving into a fascinating world, the world of tiny motors. You know about the motors in our cars and washing machines, right? But did you know that even bacteria have motors? It's true. These little guys use something called a flagellum to move around. And guess what? This tiny tail-like thing works a lot like our man-made motors. Surprising, right? We're going on an adventure to compare these two marvels, the bacterial flagellum and the electric motor. We'll see how they're built, how they work, and maybe even learn a bit about how amazing nature is. So buckle up, science explorers. Let's dive into the world of tiny motors and big surprises. First up, let's meet the bacterial flagellum. Imagine a long, thin tail attached to the bacteria's body. That's the flagellum. But don't let its simple look fool you. This tail is a powerful machine. It spins around like a propeller, pushing the bacteria through water. Now let's zoom in closer. The flagellum has three main parts. Think of it like a motorboat engine. First, there's the rotor. This part spins around just like a boat's propeller. Next comes the stator, which acts like the engine, giving the rotor power. And finally, there's a hook which connects the rotor and stator like a drive shaft in a motor. So this tiny tail isn't just a tail. It's a complex machine with different parts working together. Pretty cool, huh? Now let's move from the microscopic world to the world we can see. Electric motors are everywhere. They power our fans, blenders, and even some cars. But have you ever stopped to think about how they work? Just like the flagellum, electric motors have a spinning part called the rotor. This rotor is surrounded by magnets called the stator. When electricity flows through the motor, it creates a magnetic field. This field interacts with the magnets in the stator, making the rotor spin. The spinning rotor then powers whatever the motor is attached to, whether it's the blades of a fan or the wheels of a car. It's all about converting electrical energy into mechanical energy to make things move. So, we've seen two amazing motors, one tiny one, not so tiny. They both spin, they both have rotors and stators, and they both make things move. That's pretty similar, wouldn't you say? This makes us wonder, did humans copy the design of the flagellum when we made motors? Well, not exactly. You see, nature has had millions of years to perfect the flagellum through evolution. We humans, on the other hand, invented the electric motor much more recently. It's more likely that we stumbled upon a similar design because it's a really efficient way to create movement. Scientists call this convergent evolution, where nature and humans find similar solutions to similar problems. It's a reminder that even though we're big and clever, we still have a lot to learn from the tiny, mighty world of bacteria.